We are really close to being finished with this unit. We have a quiz on Thursday. Your quiz is going to be over lessons 1-1 through 1-5. So it's going to cover everything that we've done already. You can go back, look at your digital notebook. You'll get the whole 80 minutes to work on it. Okay, but what happens is after this unit, we start doing proofs. And we've brought in some of those terms that we're going to start seeing whenever we do proofs, such as substitution. We did justifications. We talked about justifications. We've talked about postulates. Today, we're going to talk about the word conclusion. Conclusion, in the verb sense, is called conclude. It says a conclusion is the end of an event or the last step in a reasoning process. So you have the beginning, which is the given, and then you have the conclusion, which is the end. So on your vocabulary, if it rains, you can conclude or conclusion that soccer practice will be canceled. Is that the verb tense or the noun tense? Diaz? Verb. So we're going to conclude that soccer practice will be over. The last step of the proof is the what? Conclusion. The proofs that we deal with this year are not the proofs like I dealt with when I was in high school. When I was in high school and I took geometry, we could have 13, 14, 15 step proofs. You all, I think the most that you might have is a 5 to 6 step proof. And most of them are less than that. And so you'll see what I mean soon enough, but proofs are really fun. All right, let's go to the next slide. So the other day we talked about acute, obtuse, right and straight. Today we're going to bring in different types of angles again, okay? So those are telling you how big the angle is. Well, there are some angles that have a partner, you could say. This is 8th grade content right here. So you need to put that in the back of your brain, that if we were to take a K-Prep test, which I don't know that we are, that if we were, you would probably see this on the K-Prep test. It says adjacent angles. Adjacent means side by side. In order to be adjacent to something, you have to be directly beside it. It says two coplanar. That means they're in the same plane, right? They're coplanar. Angles with a common side, a common vertex, and no common interior points. A common side, a common vertex, and no common interior points. Adjacent angles, and you might want to write this on your sheet of paper on your notes page. You weren't in here whenever. I would put side by side on these. These are adjacent angles are side by side. Vertical angles, I always say, are across from each other and they make an X. It says two angles whose sides are opposite rays. Vertical angles share a vertex. They share a vertex, but they don't share anything else. So the only thing that they have in common is their endpoint or their middle point. Okay? So vertex angles share a vertex, or vertical angles. Complementary angles you've probably heard of before. One thing I want to point out is this. Complementary angles are 2 and only 2. So it can't be 1, it can't be 3, it has to be 2. 2 angles whose measures have a sum of 90 degrees. Those angles can either be adjacent to each other, so they could be side by side, or they could be in a different picture altogether. As long as they add up and they're 2 angles to equal 90 degrees, then they're complementary angles. Supplementary angles are the same way. 2 and only 2. Can't be 1, can't be 3. Whose sum is 180. So you're adding them together. They're going to give you 180 degrees. Once again, they can either be adjacent, which is side by side, or they can be in the same picture, but separated. It says, draw a line from each word in column A to the angles it describes in column B. Supplementary. So look at column B. This is the easiest way to do this. Look at angle 1 and angle 2. Angle 1 and angle 2 share a middle ray. They share a vertex, but they have different side lengths, right? These are what we call, now look, you could also say, see that right angle right there? Can we assume that angle 1 and angle 2 make up a right angle as well? Could we assume that? We could, okay? The reason why we can is because it shows me that you can't even see that, sorry. It shows me that it's a right angle there. So I can assume that this one right here also is a right angle. And what that tells me is the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Which means because they're two angles whose sums equal 90 degrees, they're complementary. Angle 2 and angle 3. Angle 2 and angle 3. Angle 2 and angle 3 are directly beside each other. Okay? You don't know what angle 2 measure is. So you can't say that it's complementary or supplementary. Okay? But I do see that angle 2 and angle 3 are directly beside each other. Do you see that? Because they're directly beside each other, we would say that they are adjacent to each other. Yes? They do share a vertex, yes. And it says up here at adjacent, it says common side. They share a common side, a common vertex. And so that's what that's talking about. Angle 2 and angle 5. Angle 2 and angle 5. Do you see where they have a common vertex, but they share nothing else? They're directly across from each other, and their rays create an X. Do you see that? Those are what we call vertical angles. They share a common vertex. They have no other common sides. Their rays create an X. That means that angle 3 and angle 6 are supplementary to each other. We'll learn this. I don't know if it's in this lesson or not. Vertical angles are congruent to each other. Angle 3 and angle 6 are also vertical angles. But because angle 3 is 90, I can also assume that angle 6 is 90 because they're vertical. And 90 plus 90 is 180. Questions? All right, so look down at problem 1, identifying angle pairs. It says use the diagram at the right are angle AFE and angle CFD vertical angles. Are they vertical angles? It says the rays of angle AFE are ray FE and ray what? The rays of AFE are FE and what? AFE. What is the other ray, Jillian? FA, very good. The rays of angle CFD, so CFD, are angle are ray FC and ray what? Diaz? FD. Mm-hmm. It says complete each statement. Ray FE and ray FC are opposite rays. Ray FE and ray FC are opposite rays. Ray FA and ray what are opposite rays? Ray FA and what are opposite rays? Andrew? FD, very good. Are angle AFE and angle CFD vertical angles? All right, so let's look at them. AFE and CFD. Do those two angles share any other thing other than a vertex? I don't even have to look at the figure. Look at the letters. The middle letter is the vertex, right? In naming an angle. Do you see where both of them have the letter F? So they share a common vertex. Now, if they're vertical, they share no other letters. Do both of them have an A in it? No. Do both of them have an E in it? No. So because the two letters that are surrounding the vertex F are different from each other, then these are vertical angles. Vertical angles only share a vertex. Vertex is the middle letter in naming an angle. All right, so we're going to make a conclusion from a diagram. Can you conclude that line segment TF is congruent to line segment WV from the diagram? So look at the diagram. Do you see line segment TW? Do you see line segment WV? Can you conclude that they're congruent to each other? Think about everything we've talked about. Can you conclude just by looking at the diagram that they're congruent to each other? It says circle the items marked as congruent in the diagram. Does it say PW and WQ are congruent to each other in the diagram? No. But it does say that TW and WV are, because see those tick marks? Do you remember us talking about arc marks? Okay, so tick marks are the arc marks of lines. So because there's one arc mark there, there's one arc mark there, that means that those two are congruent to each other. That means they're the same measure. Go back and go to edit and undo. And it'll bring it back. And you just keep doing it until you see it come back. Can you conclude that TW is congruent to WV? Yes, you can. Because of the tick marks. Because of the tick marks.